Hello everyone, welcome back to another exciting chemistry lessons by Adrenaline, the Bazooka Prophet. And today we are going to be talking about a very important aspect in the field of chemical kinetics, talking about how to determine the unit of the rate constant of the different order of a reaction. Now we should understand that according to the rate law, the rate of a given chemical reaction is given by the rate of a reaction is equal to the rate constant K, right? The concentration of A, which is the reactant, raised to power N. This N here stands for the overall order of a reaction. This is it. Now, we should understand that we can be able to determine the unit of K for a zero order, first, second, third, or any fractional order we are asked in our exams, especially those of you preparing for AP, IB, Cambridge level exams, and NEET exam, JUPEP exam, IJMB exam, or any other A-level exams, and also college exams likewise. Now, I've been able to give a shortcut here to be able to determine the unit of the rate constant of a given chemical reaction. This is the shortcut here. It will help you ace your exam. It will help you to remember every aspect of it. Now, we continue to go deep into it. And the question says, determine the unit of rate constant K for a reaction that is K for zero order and the time is measured in seconds. So, let us solve it. Now, for a zero order now, of course, the rate will be equal to K. The concentration of A will be what? Now, raised to power 0. And remember, anything raised to power 0 is 1. And as such, the rate of a given reaction is equal to the rate constant. So, R is equal to K. Is that clear now? So, it is very, very simple. Now, we should understand that the unit of the rate of a chemical reaction, R, is equal to mole per liter per seconds. Mole per liter per seconds or per time. Now, remember, the concentration is the molar concentration, and as such, it can also be molar concentration per time or per seconds, because but in this case, they said measured in what now? Seconds. So the unit of K for the zero order of the reaction is this. Please do not forget it. Now, we move to the second one, which is for B now. They said first order. For a first order, you just remove this 0. Of course, the power of A here is what now? 1. Now, let us use this shortcut to address it. The unit of K is equal to liter per mole over the time was measured in minutes. Remember, raised to power n minus 1, whereby n here stands for what now? The order of the reaction. So it will be 1 minus 1. It is what now? 0. So an anything raised to power 0 again. I've told you, of course, in indices is 1. So it will become 1 over minute, which is the same as saying per minute. That is to say that the unit of the rate constant for a first order is per minute, or per time. Simply telling you that the first order, right, the unit of the first order, K, is independent of the concentration of the reactant. Now, this is for the first order. This is for first order. Please look at it properly. Now, the second one, which is for the second order, it is simply R is equal to K. Now, the concentration of A and the power is what now? 2, second order. So let us actually address this one. K, which is the rate constant for a second order, right? Let me put it here, second order. So what do we do? Of course, liter per mole. They said the time was measured in hours. So here is hours, right? Now take note. If this order of the second order is 2, it will be 2 minus 1. And 2 minus 1, which is 2 minus 1 is 1. So it remains like this. So the final answer becomes liter, of course, per mole per hours, right? Per hours. It can be in this format. It can also be in this format that we can use here. Of course, it becomes molar concentration, right? Molar concentration. The n minus 1 there is 2 minus 1 is also what now? 2. 2 minus 1 is 1 over the time there is hours. So it just becomes per molar concentration per hour. Per molar concentration per hour, or liter per mole per what now? Per hour. This is for a second what order. And lastly, please take note. And lastly, for a third order, where my rate is equal to the rate constant, the concentration of the reactant raised to power what now? 3. It's simple. The unit of K will become liter per mole. Liter per mole. They said in days for the time. Now remember, if the n is 3, it will be 3 minus 1, which is what now? 2. Very simple, right? So what do you do here? Very simple. That becomes liter square, right? Per mole square per what now? Per days. Very simple, right? Very, very well simple. Which can also be, if we make use of this one, to become molar concentration. Remember, here is minus 1. Here is 2. 3 minus 1 is 2. 3 minus 1 is 2. 2 times minus 1 will give me minus 2, right? Since it will be what now? Over per what now? Per day. So this is the final answer. This is the final answer. Now, if you actually understood what we have just done here now, please do well to answer for me the unit of the rate constant for a fourth order. And when you are done, drop the answer for me in the comment section. Please, if this video has helped you, do well to subscribe, share, and like. Thank you, and God bless you.